Are you still using passwords to connect to your servers or even GitHub? If you're just connecting to one server, typing the password or even memorizing it can work. But as soon as you step into a DevOps role, you will need to connect to 5, 50 or even more servers. This becomes a nightmare. And honestly, it's dangerous. Passwords are the easiest way for attackers to brute force their way into your infrastructure. Today, we're fixing that. We're switching to Ed25519 SSH Keys. It's easier than it sounds, way more secure, and it's a routine practice for any DevOps or systems engineer. And to make this production ready, I'll also show you how to harden your servers to block passwords altogether. Let's get into the terminal. Before we start typing the commands, let's quickly understand the mechanism. SSH keys work with asymmetric encryption. We won't get into the heavy math right now, we're gonna stick to the practical mental model. SSH keys work in pairs. You have a private key and a public key. Think of a public key like a padlock. You can give this padlock to anyone, your server, GitHub, or your team. It's public. The private key is the only physical key that opens the lock. This stays on your device. And of course, you never share it with anyone. So, the public key encrypts the message and the private key decrypts it. Simple. Now, regarding the algorithm. In the past, RSA was the standard, but today we're using Ed25519, which uses elliptic curve cryptography. It's faster, has smaller keys, and is the modern standard. Enough theory, now let's generate the keys. Alright, I have two Linux terminals here. One on the left is my local machine, sumbuff@client, and on the right is my remote server, admin@server. The server IP address here is 192.168.10.12. Right now, if I try to connect from the client with the SSH command, it hangs and then asks for a password. I type it in, and I'm in. This works, but it's manual and insecure. Let's fix this. First, let's go back to our client terminal. The command we're going to use to generate the keys is ssh-keygen. With that, we need to pass two important flags. First, "-t" followed by Ed25519. This tells the tool to use the modern algorithm we just talked about. Second, "-C" followed by a comment to say whose key it is. Strictly speaking, you don't need this. But trust me, when you have 20 keys in a server, this comment acts as a name tag to tell whose key it is or what it is for. It's a good habit to start. Hit enter. It's asking where to save the file. The default location is the hidden .ssh directory inside my home directory. And the file name for the private key is also the default one, which is perfect. Just hit enter. Now, the passphrase. This is critical. In production environments, for keys used by human operators, you should always set a strong passphrase here. This encrypts the key itself, so even if anyone steals the key somehow, they can't use it to hack your servers without the passphrase. However, since we're doing this for a lab, we're skipping the passphrase. Hit enter twice. There's the key art. This means our keys are generated successfully. Let's quickly verify. From your home directory, hit cd.ssh to enter the .ssh directory. Let's hit ls here. As you can see, we have two files, id_ed25519 and id_ed25519.pub. The file ending in .pub is your public key. That's your padlock. The one with no extension is your private key. Let's peek inside the contents of both files and recognize the difference. First, type cat and the file name of the private key. See that header? Begin open SSH private key. Everything between that header and the footer is your private key. A warning here, I'm showing this to you only because this is a throwaway lab key. In real life, never let this text appear on a screen. As the name suggests, a private key is meant to be a secret. Now, let's look at the public key. See the difference? It's just one line of text, starting with ssh-ed25519. This is the safe one. This is the key we need to send to the server from the client machine. To do that, we use a built-in tool called ssh-copy-id. It is pretty similar to the normal SSH command in syntax. Let's get into the terminal again. The command is ssh-copy-id -i followed by the path to your public key and finally admin@192.168. The server's IP. So, about the flag in the command, the -i refers to identity. It is used to specify which identity or public key we want to install on the remote server. But before I hit enter, let's have a quick look at the server side. I'm on the admin user's home directory and using the ls-la command to view all the files and directories here. Right now, we do not see any .ssh directory here. Now, back to the client, let's run the command. It asks for the password initially because the tool needs the permission to log in and write to the server. I'll type it in and hit enter. Now it says number of keys added 1. So what just happened here? Let's look at the server again. I'll run ls-la again. Here you can see that the new .ssh directory got created just now. Let's go inside cd.ssh and ls. We have a new file called authorized keys here. Let's cat that file. Does that text look familiar? It's the exact public key we created on the client machine. So basically what ssh-copy-id did is no rocket science. It simply copied the public key from our client machine and pasted it here on the server's authorized keys file. As the name suggests, the public keys in this file authorize anyone with the matching private keys to SSH into the server without using any password, exactly what we wanted. You can think of this file as a VIP list. If your public key is in the file, the server lets you in. Let's prove it. Back to the client, let me type ssh admin at 192.168.10.12, hit enter and boom, we're in. This time without the password. I can achieve the same results by copy-pasting the public key manually into the authorized keys file as well. But that way you would have to make sure to manually create the authorized keys file if it didn't exist, or even the .ssh directory, while also making sure you get the file and directory permissions correct. There are many ways we could mess it up, so using the ssh-copy-id command makes it so much easier. Now, let's pause for a second. If I didn't type the password, how did the server know it was actually me trying to log in? Here's what happened behind the scenes. We call it the challenge response mechanism. When I try to connect, the server generates a random challenge message. But before sending the message, the server encrypts it using my public key. Now that the message is totally unreadable to everyone else in the world, only one machine can decrypt it, the one holding the matching private key, which in this case is our client machine. Our client machine decrypts the message, reads the challenge, and sends the answer back to the server to prove our identity. This way, the server can validate the client's authenticity and allows the access since no one else would have been able to read the message in the first place. I actually broke down the entire architecture of how asymmetric encryption and digital signatures work to build trust from scratch in my previous cryptography video. If you want to understand the concepts that make all of this security possible, I highly recommend you check that video out. Links in the description. But for now, the result is simple. We're in. And here is the bigger picture. With SSH keys, we can scale up automation to a massive extent. If you have to access 100 servers from one client simultaneously, all you have to do is install the client's public key on those 100 servers once, and then you have instant access. As a matter of fact, this is the most fundamental requirement for modern agentless DevOps automation tools like Ansible to work. Or even GitHub or GitLab. Just copy and paste the public key there, and you can push code to your remote Git server directly without ever typing a password again. The applications are endless. However, we have fixed only half of the problem. Our server still accepts passwords. We still have a backdoor to our server. This means that a hacker can still try guessing or brute forcing the password to gain access to the server. Let's fix that real quick. Back to the server terminal. The SSH service in Linux uses the configurations from the sshd_config file. You can cd into etc ssh and hit ls to locate this file first. There are two files with similar names, ssh_config and sshd_config. The file we want to edit here is sshd_config. Remember, you will need to do this step with either sudo command or by using the root user. I'm opening this file with the built-in vi text editor. You can use nano if you want as well. Sudo vi sshd_config. Now that the file is open, we'd first want to find password authentication. By default, it is commented out, so let's remove the comment and change the yes to no. This disables any further attempt to authenticate using passwords from now on. While we're here, let's also find permit root login and ensure it is either no or prohibit password. Also, let's find pub key authentication and make sure it's set to yes. By default, this option is set to yes, so you don't need to change it if you haven't made any changes in the past. I'll set it to yes anyway. Now, the final step. To bring those changes into effect, let's restart the SSH service. Let's save and exit this file, and I hit sudo systemctl restart SSH. Boom, our changes are applied. Let's stop there for a second. Do not close this terminal window yet before validating if our changes are successful. A minor typo in the file and you could get locked out forever. To validate, I'm back to the client. I'm gonna try to force SSH into the server with password authentication using an additional flag with the SSH command. SSH-o preferred authentications is equal to password admin at 192.168.10.12. Enter. See that? It fails immediately with permission denied. It didn't even give us the prompt to type a password. Let's try normally. SSH admin at 192.168.10.12. We're in. While trying to log in with the private key, it just works. We just killed the password, making the server now immune to brute force attacks. I hope you were able to understand how SSH authentication keys work, how to create and use them, and also how you can apply some hardening to your Linux systems to enhance security. In the next video, we're going to look at SSL TLS certificates. We'll understand how a simple artifact like an SSL certificate encrypts the entire internet. Consider subscribing to not miss future videos. See you.